Hello Math 1, it's been a long time, but I'm back with a new video on Chapter 8. We're really shifting gears away from graphing linear equations, solving linear equations. The whole idea of getting x by itself is not going to show up in this chapter at all. So, what are we dealing with? Exponent properties. So we talked about with order of operations what it means to be a little number right there. It just means that I'm taking this base times itself that many times. So the first thing I want you guys to consider is x to the 6 times x to the 4th, which could also be written like this, right? So what does product of powers mean? Yeah? And then what's the, answer to this question, to this prompt? Well, product of powers means we're multiplying. So, product, multiplication. Remember, difference was subtraction, sum was addition, quotient was division. Product is multiplying more than one term that has both a base, which is x here, and an exponent, which is the 6 and the 4 there. So what's the answer? X to the 6 times x to the 4th? Well, what we can do is we can expand the x to the 6 as x times itself 6 times. 1, 2, 3, 4, 5, 6, right? And then we could expand the x to the 4. We'll put it in a different color so we can see it more starkly contrasted. 4 times. So, if you look at it like this, it's x times itself 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So the answer is x to the 10. So the question is, can we glean some kind of rule from this example? And the answer is, we can. In most textbooks, it looks like this. X to the a power, which just means any constant a, times x to the b power. Notice all we have to do is, if they're the same base, right? If it's the same variable, if it's the same number, x, then what you can do is combine them to one base and then add the two exponents together. This is called the product of powers rule, which means anytime you multiply two terms with the same base, you can just add their exponents. Awesome. So what does it look like in the context of something like this? What happens when we put 1, 2, 3 of these together and they have big numbers out front? Now, when you think about it, the big numbers, by the way, they're called coefficients. These are coefficients. Yeah, and you know what? There's going to be a lot of new vocab words. Maybe not new, but ones that maybe you just haven't nailed down as you know exactly what they mean. Exponents for the little numbers. Coefficients for the big numbers. The bases are the x's. The terms are each individual one. We'll get to that later. Anyway, how would you think about this example? Well, all this represents is just a ton of multiplication. This is 8 times x to the 6. This is 7 times x to the 5. And this is 4 times x to the 3. And with multiplication, you've got this thing called the commutative property, which means it doesn't matter what order we multiply. So I'm thinking to myself, I can't really reduce this right here, but if I got the 7 with the 8 and the 4 with the 7 and the 8 through the commutative property, so I said this is 8 times 7 times 4 by just rearranging the terms, and then I multiply that by x to the 6 times x to the 5th times x to the 3, then it seems like it makes sense that I could just take 8 times 7 times 4, which if we use our calculators, it's going to be 56 times 4, which is going to be 224. So I've got a new coefficient of 224. See, I literally multiplied the coefficients. And then I used the product of powers property the product of powers property, pop, that's going to be x to the 6 plus 5 plus 3. So it's going to be x to the 11, 14. And that's the simplified version of what's going on. So I multiplied the coefficients, and then I added the exponents. So if you can wrap your mind around the terminology, the difference between an exponent and a coefficient, I think you guys will do well with this lesson. So let's do some examples where we're using this. So I got 3 examples where we're going to try to figure out the product of powers property. So when I see this right away, I think a good visual cue for you guys starting out is to really rearrange things. Don't try to do everything in your head. So I see the coefficient 2 times 4. So I'm just using the commutative property to rearrange things. Maybe in a different color, I'll do the a's. So now I've got an a here and an a to the 3 there. By the way, this a has an exponent of 1. Don't forget about that. The b's I'll put in a completely different color. B squared here, b squared there. And then the f's are going to be f squared here and f squared there. So if I just rewrite my terms like this, then I can say coefficients get multiplied, exponents in their properly same base. The ones with the same base, their exponents can get added. So it's going to be a to the 1 plus 3. That's 4. This is going to be b to the 2 plus 2, which is also 4. And this one's going to be f to the 2 plus 2, which is 4. All right. You guys pause the video and try number 2 on your own. All right, let's check it out. Did you rewrite the 8 and the 4 together? Did you rewrite the x's together? By the way, I'm going to put the x's first just to keep things in alphabetical order. It's a really easy way to organize things. The y's should be rewritten side by side, y to the 7, y to the 6. The z's, z to the 6, and z to the 5. Okay, so 32, because I multiply the coefficients, and then I add the exponent for the x's, that'd be 10. I add the exponent for the y's, 13. I add the exponents for the z's, 11. All right, one last example to try on your own. Again, pause the video and see if you come up with the right answer. By the way, look at this. I got marker all over my sweatshirt. That's why I'm going to just stick with one marker from here on out, juggling 4 of them. Obviously, I'm not talented enough to do that. All right. You guys paused it. You tried it on your own. -4 and 6, I'm going to group those together. If you want to put parentheses just to really separate things, I would encourage you to do that. A to the 3, A to the 6, put them side by side. B to the 4, B to the 1, don't forget that 1, C squared, C to the 10. All right, you multiply those coefficients, you add the exponents. That'd be 9, 5, 12. Yeah, pretty simple properties, and when you practice it, you get into a cadence where it's not going to be very difficult to separate when do I multiply and when does actual addition of those numbers happen. All right, that's half the lesson. The other half is rooted in the second property of exponents that we're going to be talking about today. And I'm just going to ask you guys to consider x to the 6th power and then taken to the 3rd power. All right, so this is x to the 6 to the 3rd power. And all that means is that I'm taking x to the 6 times itself 3 times. So I got 1x to the 6th, 2x to the 6th, and then 3x to the 6th. And here's the deal. We can now use the product of powers property. We can say same base. All I got to do is add the 6 3 times to itself, which ends up being x to the 18. So x to the 6 to the 3rd power equals x to the 18. Now, you can do this if you want to and only have to memorize one property. However, wouldn't it be better to say, adding something to itself multiple times, we figured out a shortcut for that back in like 2nd grade. Multiplication, right? So if it's x to the 6 to the 3, why don't I just cut out this step right here and say this is x to the 6 times 3? Because that's exactly how it works. So this is our second property. All right, in a lot of textbooks it's called a power to a power property. So the power to a power property is if you've got x to the, I'm going to call it c power, okay? It's just so we don't get it muddled with the a's and b's from the first property. X to the c to the d power, where c and d are just constant numbers, that equals x to the c times d. All right. So how does that work in an example like this? Well, all I got to do is say, what's your exponent? That's going to get multiplied by 4, okay? So you've got y to the 6 times 4. See how that works? And then I'm going to have x to the 3 times 4. Now here's where people get super confused. The coefficient itself does not have an exponent that's kind of listed in the directory. It's like, y has a 6 exponent, x has a 3 exponent. What does the negative 2 have? Well, negative 2 has an exponent. It's just kind of hidden in the mix of things. There's one negative 2. So it's negative 2 to the 1 power times 4. Okay? So all I'm doing is saying I'm applying the 4th power to all 3 parts. And it's not negative 2 times 4. It's not negative 2 times 4. It's negative 2 times itself 4 times. Okay? So when you think about that, what is negative 2 times itself 4 times? Well, negative 2 times negative 2 is positive 4, right? Times negative 2 is negative 8. Times negative 2 is 16. Negative 2 to the 4th power is 16. And there's your final answer. So that'll be the one thing that you will really have to try to break a habit of, is you're going to want to put negative 8 down, but it's 16 because you're multiplying it by itself. Let's practice. Check out number 4. By the way, the calculator can do a lot of helping with this concept, right? If you're not sure, there is a button on there that can help you out, which I think it'll be better for me to just show you how that works when you guys are in class. I could probably show it here too. Let's just see where the examples take us. Number 4. All right, so negative 3ab to the 4 power. So this is negative 3, no exponent listed, so I'm going to give it an implied 1. A Now the fourth power is not attached to the a, it's attached to the b. So you're going to say it's just a, that's just a to the 1. And then b to the 4. Okay, now I think we've got a better task ahead of us. It's going to be 3 times 4. That's going to be b to the 12. Okay? 3 times 1. That's going to be a to the 3. 3 times 1. It's going to be negative 3 to the 3 power. And then you can take negative 3 times negative 3 times negative 3. Which turns out to be negative 27. Not negative 9. Right? You're not taking negative 3 times the 3. You're not doing that. All right. Try number 5 on your own. All right, you guys have paused it. You've tried it. Let's see what you made of it. So this is going to be 1, no exponent given, to the 1 power. G to the 2, H, no exponent given, so I'm going to make it to the 1 power. K to the 4. All right, I'm ready now to distribute that 7. It's going to be 7 times 4, which is going to be k to the 28. 7 times 1, which is h to the 7. 7 times 2, which is g to the 14. 7 times 1, which means it's 1 to the 7th power. Now, 1 times itself is 1, no matter how many times you multiply by itself. So this is not 7. This is 1. All right, and then one last example for you. What do we make of these brackets? I'll read it, write it so you guys can see it better. So parentheses here, brackets here. Well, all brackets are signifying is that we've got one group inside that's being taken to a power, and then this entire group is being taken to another power. Brackets are basically like parentheses again. All right? So the question is there a way for us to talk about x to the c to the d to the e, right? That's really what's happening here. 1, 2, 3 powers, 1, 2, 3 powers here. Since multiplication works for the inside here, I could just say it's x to the cd to the e power. And then any power to another power is multiplication again. So it's x to the c times d times e. Basically what I'm saying here is that if you see brackets, it just means if I multiply that outermost exponent times this one here, I can eliminate the complex bracket structure and just call this negative 2ab to the 4 to the 15th power. Okay? It's still just multiplication. All right, now we do like normal. It's negative 2, no exponent, to the 1 power. A, no exponent, to the 1 power. B, to the 4. Everybody is being taken to the 15. That means 15 is going to be multiplied by all the little tiny numbers that represent the exponents. So you got 15 times 14, which comes out to be 210. So it's b to the 210. And then it's going to be a to the 15 times 1, which is just a to the 15. And then, negative 2 times itself 15 times. And this is the point at which you guys might want to use a calculator so you're not typing -2 times -2 15 times. All right, so if you look closely on a calculator, all right, you usually see this little button, we call it a caret button, right here. So what I can do is I can put parentheses around my -2 like this, and if it's a negative number, you need parentheses. Sorry I'm so close right here. I know, we should be maintaining social distance. I want you guys to see this. I'm going to hit that caret button, and then I'm going to hit 15. And what it's telling the calculator is, take -2 times itself 15 times. I hit equal, and I get a big number. It's -32,768, and that's going to be the coefficient in front. All right, guys, so do your best with this remote lesson. I think that clearly explains most of it. You got 10 problems to work with. Try to get it done by tomorrow, and then we will see where we're at. All right, thanks for watching.